Welcome to the deep dive. We often hear those comforting phrases, don't we? Things
Hmm.
like genetics predisposes but doesn't determine, or, DNA is not our destiny.
Right. Comforting, but maybe not always the full story.
Exactly. Well, today we're diving deep into a specific molecule that might make us rethink those notions a bit, but importantly, it's also about empowering us with knowledge.
Okay.
We're talking about lipoprotein, or you'll often see it as LPA.
PA.
Yes. It's highly hereditary, can significantly impact your health. But, and this is key, our mission today is really to explore how we can modulate it, how we can manage it effectively.
Good. Because there are things we can do.
Definitely. We've got a detailed analysis here covering LPA, its risks, and crucially, some powerful management strategies to unpack for you.
Great. Let's get into it.
So, a lot of people, maybe like our listener who prompted this deep dive, they first encounter LPA during a comprehensive blood test.
Yeah, it pops up on the panel.
Right. You get the results, you see this LPA value, maybe it's above 30 milligrams per deciliter, perhaps the lab flags anything over 50 or 60.
Hmm.
And then, curiosity strikes, you jump online,
Oh, yeah. Dr. Google.
and suddenly the information feels, well, pretty alarming. It's natural to be alerted, totally, but the goal is understanding, not just overwhelm. Okay, let's unpack this.
Well, exactly. And to really get LPA, we first need to sort of reframe how we think about cholesterol overall.
Okay.
I mean, for this audience, you probably already know cholesterol isn't just good or bad. It's actually vital. It's pure energy, essentially.
Right.
It helps build the membranes for every single cell, transports energy for, crucial sexual hormones. It's part of the myelin sheath on our nerves. Super important for vitamin D synthesis.
Essential stuff.
Totally essential. So the question is, when does it become a problem? Well, it really only turns pernicious when it's combined with a metabolic environment that is oxidized or, importantly, persistently inflamed.
That's the context.
It's all about the context. Now, LDL, the one often called bad cholesterol, it's just transporting energy from the liver out to tissues, like the brain. It has a tag, apolipoprotein B, ApoB, like its address label.
Got it.
And HDL, the good one, carries that boy one. So, when we think about forcibly lowering all cholesterol with meds like statins, there can be wider effects, maybe even affecting brain energy. Some report depression, for instance. But our focus today with LPA is how its presence makes things stickier.
That's a really helpful distinction, the environment, the context.
Yeah.
And that's exactly where LPA comes in, right?
Yeah.
It's found alongside that LDL and ApoB.
Precisely.
And you said when LPA is high, it makes the whole molecule stickier. That's the term from our source, and it really paints a picture.
It does. It's a good description.
So this stickiness, especially if there's that persistent inflammation we talked about,
That's the kicker.
it can lead to forming these more agglomerated plaques, obstructions.
Exactly. And that's where the serious health implications start.
Okay, so what are those?
Well, these plaques, they significantly raise the risk of arterial hypertension, high blood pressure.
Right.
And the danger really ramps up if these plaques break off. They become thrombi, blood clots.
Okay, that sounds bad.
It is. These clots can cause an ischemic stroke or even a hemorrhagic one, you might see it called an ACB, acute cerebrovascular accident, or pulmonary thrombosis if it goes to the lungs, or, a heart attack if it blocks a coronary artery.
Wow.
But, and what's fascinating here, there's another layer to LPA, its chemical structure. It's remarkably similar to plasminogen.
Plasminogen. Okay, what does that do?
Plasminogen is the precursor to plasmin. And plasmin is essential for managing blood coagulation, basically breaking down clots when they're not needed.
Ah.
So if you have high LPA and that pro-inflammatory
The
environment,
bad combo again.
right, your body can actually get confused. It might mistake LPA for plasminogen. And this leads to poor coagulation management, meaning you're more prone to thrombosis, to clotting.
So you've got this sticky plaques and a problem with clot breakdown.
Exactly. You combine those atheromatous plaques with this potential for runaway clotting. That signifies a very high cardiovascular risk. No wonder high LPA sets off alarm bells.
Yeah, absolutely. That makes perfect sense now. So, wow. Okay, so what does this all mean for us? Why is this specific molecule so heavily tied to our genes?
That is the big question. And the answer seems to lie way back in our ancestral history.
Our evolution.
Kind of. Think about ancient tribal life. You had different roles, right? Collectors, herders, builders.
Sure.
But you also had warriors, soldiers, people facing constant physical threats,
Yeah.
injuries, cuts, fractures, infections. It was just part of daily life for them.
A much rougher existence.
Definitely. And it seems LPA played a vital role for those individuals. It provided resilience and greater adaptation to that hostile environment,
Yeah.
helping with wound healing and fighting infection, perhaps. Faster clotting could be life-saving then.
Ah, so it was protective.
In that specific context, yes. So if we connect this to the bigger picture, it makes evolutionary sense that this trait got passed down genetically. A warrior's child, likely also facing similar dangers. So inheriting high LPA would give them better resilience, better survival odds.
So it was like a genetic advantage passed down for a specific dangerous lifestyle.
Precisely. A survival mechanism, really.
It really paints a picture, doesn't it? Our bodies are carrying these echoes of ancient dangers. Dangers most of us, thankfully, aren't facing daily anymore.
Right. We're not typically fighting off saber-toothed tigers or getting wounded in battle. And antibiotics have drastically cut down infection risks.
Yet this high LPA trait, it remains. It's like, as the source says, a mark, a brand burned into our genetics, up to 90% genetic predisposition.
Yeah, it's a very strong genetic link. We see it's particularly common, for instance, in people of African descent, likely reflecting some ancestral advantage in that lineage.
So, okay, if 90% is genetics, wow, that remaining 10% are epigenetic habits. That becomes unbelievably important, doesn't it?
Supremely important. Because if your lifestyle choices, that 10% you do control, create that inflammatory oxidized environment we talked about,
You're setting the stage.
you're creating the perfect storm for that inherited LPA to become really problematic. And that's why it's absolutely critical to remember you must look at LPA in the context of everything else, all the other blood markers, not in isolation.
Right. It's one piece of a much larger puzzle.
Exactly. So what can we do about that 10%? Let's get practical.
Please, what are the actionable steps?
Okay, first off, your food plate. Think of it as your daily genetic test, in a way.
Okay.
If you're constantly eating refined, ultra-processed foods, maybe transgenic ingredients, you're likely feeding inflammation. You're creating that pernicious environment.
The danger zone.
Right. That's where LPA gets sticky and dangerous.
Yeah.
So conscious eating here means focusing on whole, unprocessed foods, things that calm inflammation. And also avoiding constant snacking. Aim for, 2, maybe 3 distinct meals a day. Give your system a break.
Makes sense. What's next?
Next, and honestly, this might be the most important key for managing LPA, restorative sleep.
Sleep.
Absolutely. Your liver, it produces, manages, modulates all your cholesterols, including LPA, and it does its best work, its repair work, during real, deep, nightly restorative sleep.
Huh.
So you need to cultivate a consistent culture of rest. Sleeping more than 8 hours, restoratively and crucially, at night when your circadian rhythms expect it. That's probably the single best non-pharmacological way to help manage LPA.
Wow. Okay, sleep is huge.
Then what? Then movement and exercise. Remember, cholesterol is tied up in energy management.
Right, transporting energy.
So you need to use that energy, get moving. And I mean both general physical activity, just not being sedentary, but also structured exercise.
What's the difference in this context?
Well, exercise means things like resistance training, running, cardio, HIIT, functional training, stuff that moves your joints and muscles, yes, but importantly, trains your cardiopulmonary and cardiovascular systems. It helps your body handle energy efficiently.
Got it. Diet, sleep, exercise. What else?
The final piece is managing persistent stress.
Stress. Always comes up.
Because it's real. If you're under constant psychocognitive or psycho-emotional strain, you're constantly draining your energy reserves.
Like running the engine too hard, too long.
Exactly. And with high LPA, that chronic energy drain can worsen how energy is distributed, potentially contributing to those obstructions, to hypertension. Plus, remember the plasminogen mimicry?
Yeah, the clotting issue.
Chronic stress can exacerbate that too, potentially messing with coagulation. So the bottom line is, if you know you've inherited high LPA, you really need to prioritize doing everything well across all these areas: diet, sleep, exercise, stress management.
That's actually quite empowering, though. Even with the genetics, there's a lot within our control through habits.
Absolutely.
Okay, that makes sense. So beyond those foundational habits, this raises an important question. Are there specific supplemental tools that might help?
Yes, there are. But again, these are assistants. They work best within the context of those solid lifestyle habits.
Right. They don't replace the basics.
Definitely not. So first, omega-3 fatty acids. Very useful because they help reduce oxidation and inflammation. Remember, high LPA is most dangerous in that oxidized, inflamed environment.
Okay, omega-3s. Good.
Vitamin C, also great as an antioxidant. Vitamin D, important for overall immune function, which plays into inflammation.
Standard helpful vitamin.
Then there's niacin, also known as nicotinic acid.
Niacin. I've heard of that.
Yeah, it can help with vasodilation,
Yeah.
basically widening blood vessels to allow more blood flow. However, and this is really important, niacin must be very well supervised by a healthcare professional.
Why the strong caution?
It can have side effects for some people. Flushing, redness, sometimes abdominal pain or indigestion. It's a powerful tool, but it needs careful guidance and monitoring. Not something to just grab off the shelf without advice if you have high LPA.
Got it. Supervised use only for niacin. Anything else?
And finally, coenzyme Q10 or CoQ10.
Ah, for energy.
Exactly. Since we're talking about this inherited challenge in energy management and distribution, CoQ10 provides pure mitochondrial energy.
Yeah.
It helps improve the whole cellular energy situation, which can be beneficial when dealing with the downstream effects of high LPA.
Okay.
So yeah, while genetics definitely predispose you, these good epigenetic habits, the diet, sleep, exercise, stress management, plus some targeted context-appropriate supplements like omega-3, C, D, supervised niacin, and CoQ10. They can really help tame this LPA, help regulate it. And then you can track it with blood tests maybe every 6 or 9 months, see how things are going.
So there you have it. It's a complex picture, isn't it? While lipoprotein is largely hereditary, carrying these fascinating echoes of our deep ancestral past, we actually have quite powerful tools. Our daily habits, specific supplements used wisely, they give us a way to manage its impact on our health today.
It really is about taking that knowledge, understanding the why behind it, and using that to take responsibility. It empowers you to guide your own health journey.
Absolutely. And it leaves us with a final thought to consider. Considering how deeply rooted LPA is in our ancestors' survival needs, what does this tell us about other hidden evolutionary trade-offs our bodies might still carry? And how can understanding these ancient adaptations actually better prepare us for the unique health challenges we face in our modern world?
A fascinating question to ponder.
Indeed. Thank you so much for joining us on this deep dive today. We really hope this was helpful, and we encourage you to keep exploring, keep learning about your own health.